Hey, everybody, how's it going? Y'all still waking up? For those of you who don't know me, my name is Tristan Bietsch, and I'm the founder and CEO of BitEscrow. And this is a company that has been in the works for the past 2.5 years. So for those of you who don't know, BitEscrow is the next industry standard for escrow, for not only just Bitcoin, but for fiat as well. And the way we're doing that is we are completely revolutionizing Bitcoin smart contracts. So we're building 3 things. The first one is an application for grandma to use so she can escrow her Bitcoin safely when she's buying a house. The second thing we're building is an API for developers. And the third one being is an agent marketplace for people to find agents to invite to their transaction. And today, I'd like to fully announce that we have a full beta API launch with full documentation. All right, y'all clap, but why is this a big deal, right? Why should everybody care about this, right? Well, there's 3 big main reasons. And the first one being is that this is, again, like I said earlier, going to completely revolutionize Bitcoin smart contracts, because what we're doing is we're bringing Bitcoin native, non-custodial smart contracts to Bitcoin. And what this is going to do for developers is create a marketplace renaissance. So in the future, you will see thousands upon thousands of marketplaces being built on top of this. And the reason for that is because as of right now, there are 0 dedicated escrow APIs for not only cryptocurrency, for Bitcoin alone. Because right now, they all aren't that great. But the real reason why this is a big deal, for the first time in Bitcoin's history, you'll be able to reverse a Bitcoin transaction, which is a huge deal. So some of the features of this I'd like to talk about are 6 main ones. The first one being is that this is integratable with almost anything. So, ChatGPT to Zapier, this API is going to be the Zapier of Bitcoin. The second one being is it's bridgeable between not between only other blockchains, but with banks as well. So ACH payments, if X happens, Y. The third is that it's very scalable. So whether you're a startup or an enterprise, our API can handle any amount of traffic. The fourth one being is that it's super, super simple to use. I mean, dead simple. Simplifying the sophisticated is really hard, and we've narrowed it down to SDKs and libraries for developers to use. And the developer experience has been everything with our company. And it's very secure. And I mean, people say that all the time with what they make, but this is on the bleeding edge of cryptography standards. So much, in fact, that we've made new ones. And the last one being is that it's pretty damn sweet, meaning that we have a full SDK, test suite, APIs, and libraries for developers to build whatever they want using our API. So with that all said, I'd like to introduce my co-founder and CTO, who's been nothing but great in the past year, Christopher Scott.
Hello. All right, how are we going to do this? My notes are right here. Okay, hi. So I'm Topher Scott. I'm CTO of BitEscrow. And today I'll be giving you a brief run through of the protocol that we use for building smarter contracts on top of Bitcoin and with non-custodial escrow of the funds, which I think is pretty cool. So yeah, I'm going to be fumbling through my notes here on my phone. That's just the way I guess this set up. But yeah, so each contract has 3 distinct parties involved. So you have the members of the contract. They're the ones that set up the terms, and they're the ones that also are going to be negotiating the settlement. You have the funders of the contract. They're the ones that deposit the Bitcoin, of course. And then you have the contract service provider, which is us. So members can also be funders in a contract, of course. But from our perspective as the contract provider, we can't tell if they're the same. So we're actually blinded from knowing if there's any link there. Okay, so there are 3 phases in the life of a contract. You have the negotiation phase. This is where we negotiate the terms of the contract. We have the funding phase. This is where we deposit the Bitcoin and create the signatures. And then we have the settlement phase. This is where we negotiate the settlement of the contract. Yeah, and so this is the spookiest slide of the deck. So It only gets better from here. But this is what a basic contract looks like on our platform. So this is an example of a basic buyer-seller agreement with a third-party dispute resolution, i.e. arbitration. It's meant to be readable for humans and machines alike, but mostly humans, hopefully. So let's walk through each field here. So basically, title, short description of the contract. Content is a custom field that you can use for your own things. Duration sets the max duration of a contract before it expires. The network is self-explanatory. Paths and payments. So paths and payments are used to create a set of transactions that the contract can spend from. Each line item in paths and payments, you can recognize there's a output value and then there's a wallet address. So these are used to create a set of transactions that can be spent under certain conditions. So for example, a payout transaction or a return transaction. Value is the total amount that will be in escrow. Each transaction must equal this amount essentially. So you can see payout plus payment equals like 90 plus 10 equals 100, 90 plus 10 equals 100. So this is valid. Programs are used to select or modify any of these transactions in the set. So you can define a program by listing which actions can be used, which transactions you can interact with, and which members are able to call up that program. And you reference a member by their pub key. The actions you can take are very basic right now. It's just like lock a transaction, release it so it can be used, dispute a transaction from being spent, resolve that dispute, and finally close the contract. Schedule is, last but not least, it allows you to specify actions that run automatically at a specific time. And so this is useful for certain things like time gating certain transactions, like if you have a futures contract or something and you want to change which transactions can be spent over time, or if you want to guarantee that a contract will close before it expires. So how do you negotiate this contract? Well, there's three approaches you can take. So the coolest approach is peer-to-peer. So you can negotiate the contract peer-to-peer without our involvement. We don't need to be involved at all. And we built a tool for doing this over Nostr using encrypted rooms, which is really cool. So that's an option you can take. You can also choose to use us for negotiation. This is the least secure way to do it, but we do offer it as an option. But the coolest way to do it is through a third party. We pretty much designed this to work with third parties that want to offer their own contract services. So a third party like ZapRight, John, are you in here? ZapRight could be a third party. And they can help negotiate a contract, and they can also insert their own services into that contract, such as arbitration, dispute resolution, whatever. They could be an Oracle maybe. So anyways, once you negotiate this contract, you publish it on our platform. Then we get to the funding stage. This is the cool part. So we start by creating a 2 of 2 deposit address. I think everybody here pretty much knows what that is. So we create a 2 of 2 deposit address. We also include a refund path that's time locked. Worst case scenario, me and my CEO get hit by a bus and your money gets stuck. Well, you just wait out the time lock and you take it back. But anyways, so you create this address and everything's on the funder's side. So all the funder has to do is verify the contract terms and the refund path are correct. Once they do that, they can deposit the Bitcoin into the address safely. Then they sign those transactions that came from the contract. And they also tweak each signature with the terms of the contract. And this is something that we do to set up a fraud proof later on. But anyways, once you do all this stuff, you can just deliver it back to us, and then we hold on to these signatures. Okay, and so this is what it looks like to actually negotiate with the contract once it's fully funded. So we have a little VM that runs and basically represents like the logic of the contract. So the VM is initiated by the terms of the contract, like the duration, all that stuff. It's plugged into the VM. And if you want to interact with the contract, all you do is you send us these signed messages, signed with your pub key, and we put them into the contract and we run it, and then we see what we get out the other side. So for example here, this is a message that's signed by Alice and Bob. Let's say Alice and Bob are in a contract. They agree that they want to settle the contract, so they want to close it out, and they want to close on the payout transaction. So they're happy with that. So they create this message, they both sign it, they give it to us, we put it into the VM, it runs, and there's this program that we specified in the contract, that's what we saw earlier, and it basically checks everything to make sure it's valid, that the signatures are good, Alice and Bob are there, they both co-signed, and they're allowed to close the contract on this path. So once that's done, updates the VM, and if it looks like the contract is settled, it spits out an output. And along with that output, it spits out a hash. And so another cool thing that we do here is something that we use in JIT, in version control, is that every time we update the VM, we actually we create a hash commitment, and then we chain them together. So each time we update the VM, it spits out a hash. That hash is a proof of execution that we use, that you can use to validate that we executed the contract fairly. Okay, so what is our security model? So let's run through this real quick. So yeah, so members and third parties can blind us, the contract service provider, to negotiation. Members can use an independent party for arbitration, so we don't handle arbitration. Third parties handle arbitration. Members and funders can verify all terms before they deposit the Bitcoin. Funders decide what transactions to include in the covenant. So we can't coerce funders to sign transactions. They decide what transactions to sign. All parties have consensus on contract execution. That's why we don't do arbitration. Cheating is virtually impossible to get away with. And contracts with single outcomes are essentially trustless. So if you don't want to use multiple transactions in your contract, you just want to do something simple like a vault or a coin join or a fundraiser, there's only one output, then you have the strongest security model there is. We're essentially just a coin join coordination service at that point, which is also really cool. So what are the current risks? So there's two outstanding risks that I want to address. The contract service provider can censor you by ignoring your messages and refusing to provide a receipt. So that's one risk that we have to cover. Another risk is that the contract service provider can also be hacked, threatened, or coerced to broadcast the wrong transaction. So this is only a risk for certain contracts, like we just talked about earlier. If you're just doing coin joins and stuff, it's not really an issue. But having one provider is a central source of failure. So how are we going to address this? So this is our roadmap, and I want to go over a couple of things on here. So first, we are looking into doing proof of delivery over Nostr. So the cool thing about Nostr is that it sort of gives you this distributed network of consensus on a message being delivered. The relays hold on to these messages, and you can check the relays to see if a message exists, and multiple parties can essentially use the same relays and have a consensus on what messages have been broadcast. So that's only half of the equation. Like currently relays are just too dumb to really do anything useful with that information. But we would like to set up some relays that actually offer some sort of signed receipt that messages actually have been delivered to their recipients. So that's one way we can prove delivery so that a contract service provider can't censor you. Another thing that we can do is instead of having one contract server, we can actually have a federation of contract servers. So the 2 of 2 addresses that we use are actually using MUSIC2, and MUSIC2 is the protocol that's used for Frost. So we're really just one step away of implementing Frost and doing the contract service provider as a federation. So that's another way of dealing with situations where one server can be vulnerable, but a federation of servers could not. And then last but not least, we are looking into doing this over Lightning. So something like essentially where we're a Lightning service provider in a sense, everybody's connected to us. So one of the things with doing escrow on Lightning is that it doesn't make any sense after going one hop, because every additional hop that your payment goes in the network, you're locking up excess liquidity that you don't need to. So it really only makes sense to kind of have an LSP model where everybody just connects to you and you're the mediator. So we're looking into doing that, but with smart contracts. And then finally, it works today. So this is the why should you, thank you. This is the why you should use us slide. Because it works today. The integrations are actually really simple, so that the way this is set up is that it's really easy to hook other APIs into our smart contracts so that they can control the contract. It's also cheap and private. So this is thankful to Musig. So Musig, essentially, when a contract settles, you can't tell anything at all. It just looks like a simple coin join on the blockchain. There's no information, no scripts, no nothing, which is great. Bring your own VM. So the way the protocol's set up, we have a VM that we created just for basic functionality, but you could really insert any VM that you want, provided that the VM you can prove the execution. And Frost, like I mentioned, so this is all compatible with Frost, so that's going to be on our roadmap to implement, and Lightning as well. So we're going to be compatible with Lightning, and we're excited to work on that in the future. And yeah, so this is our developer website, and come build something awesome. Thank you.